Yes, we've seen some fascinating images from James Webb Telescope, but this one is going to blow your mind, which is from the Orion Nebula, and these images that are released currently are near infrared regions, and this is fascinating because there are some interesting characteristics of these images, one coming from Hubble, and that is different from that of the James Webb Telescope. We're going to look at that. We're going to look at some fascinating characteristics of this Orion Nebula and how these characteristics in terms of specific regions in this image that we have here will change your understanding about the formation of stars and also how our sun maybe have some impact or may be impacted by this particular nebula, which is right over here. So let's dive into this particular video. Now, according to this article, it says how we can actually see the Orion Nebula, and yes, you can actually look at it through a binocular, and if you're looking at it in terms of the time of the day, it's usually around dawn, an hour after, and looking eastward you can see the Orion Nebula, which is around the Hunter region of the constellation. So it's really fascinating to see how you can take advantage of this view, but also get a better view is actually using the James Webb Telescope and a little bit of the Hubble telescope. So now this nebula is also known as the M42, which is a stellary nursery, and this is home to newborn stars. Now, speaking of newborn stars, this is truly fascinating because indeed it is really close to our own space, which is our solar system region. So if you're thinking about that and you're thinking about new stars being formed, this might be a potential theory according to scientists that indeed our sun was maybe formed at that particular stellary nursery, which is the M42, of course, the Orion Nebula. So this is really a huge target for scientists to explore more about it, and maybe 4.5 billion years ago, formation of our sun and our solar system began in that particular region before the expansion of the universe and all that things that follows after that. Now, when you look closely without the telescopes, of course, you see a really diffuse gas and dust combination that is noticed around the Orion Sword Belt region, and it's really fascinating to indeed recognize the brightest of this particular nebula in this particular system, and truly fascinating that it is of course 1,300 approximately light years distant from our own view. So indeed, when we actually dive in details in terms of its look from the James Webb Telescope using the specific near infrared region, this is actually a composite image, as you notice right here, in the sense that you're having different wavelengths of light reflected from ionized gases to hydrocarbons to molecular gases and dust, and then scattered starlight that is shown in this particular image. And we're going to see specific regions that are 4, and we're going to dive in detail about the 4 different characteristics that are observed using the James Webb Telescope. Now, the one thing that you notice on this particular image is the sword-like imagery that represents the Orion Bar, and this Orion Bar is a ridge that is of dense gas and dust that is actually lit up. When you look at the far corner right side of this screen, you see a particular region where there's a lot of cluster, which is called the trapezoid cluster, and this here is just out of the shot. So this is really fascinating because there is a lot of young massive stars at that particular nearby region, and this is fascinating to see how that impacts this particular Orion Bar. And we're going to talk about how this Orion Bar is potentially created based on analysis from this particular image right here. When you look closely at the Orion Bar, you actually notice that this is actually created by ultraviolet radiation that are released by young stars that are being formed. Therefore, this is really amazing because astronomers actually believe that these are potentially where stars, young stars, alongside planets are actually created. Now, this place is actually also known as the photodissociation region, also known as PDR. When you look closely inside the nebula, which is seen by the James Webb Telescope, we notice some fascinating features here, which includes the following. First, at the top right corner, right below the trapezoid cluster, we see a specific type of young star, and this young star has an interesting property, which is a cocoon, and around it is a particular disk. This young star is considered to be a baby star that is in this cocoon. The disk is considered to be gas and dust around this young star, and this young star is indeed called the JWST. not the taxes. 10, and this may be forming planets around this. So it's going to be interesting to see more about this particular region and understand how solar systems are actually created just observing this particular region in this Orion Nebula. Now, right below the Orion Bar on the far right is an interesting filament that actually shows the presence of hydrocarbons, lots of those alongside that of hydrogen that are present in there in terms of the chemical composition. Now, it's going to be fascinating to determine the chemical composition of this particular filament region in terms of the presence of hydrocarbons, what type of hydrocarbons are present in there. Maybe this might spark conversation about potential for formation of terrestrial planets in the future, because this is known to be called a region of high solar system building, mainly speaking of the specific stars and also closer to our sun and all those interesting ideas that might spin off from this particular region here. Now, moving on to the left below the Orion Ridge or Orion Bar, we notice a particular region that is titled to be called Theta Squared Orionis A. Now, this is known to have multiple stars that are in that particular system that is showing that particular illuminating light present in there. Now, when you move a little bit up on the left, which is right below the Orion Bar, we have a particular young star that is inside a GUA Blow, and this is actually known to show gravitational unstable clouds that is really crucial for the understanding of nuclear fusion. And this is really fascinating because of this particular idea of this collapse of gases and dust into an embryo that slowly grows in size before becoming this particular reactor. So it's really fascinating to see all these images and building understanding of characteristics of star behaviors and formations just looking at this particular region in space, which is the Orion Nebula. There is an additional image that was released by the PDR, which is also known as the Photo Dissociation Regions for All ERS team, and this incredible image shows some stunning view of the northern regions of the Orion Nebula, and this again shows the incredible filaments that are actually present in there with diverse range of colors going from dark green to a little bit of lighter yellow at the top right corner. And this observing view looks into the past according to a particular analyst in this particular article. These regions are important because they allow us to understand how young stars are influenced by gases, and also they influence gas and dust clouds that are born in particular sites where stars are born, like for example our own sun. So it's really wonderful to see how that collaboration between gas and dust and how it's influenced by young stars trigger the formation of suns, and like for example our sun. Potentially that can give an interesting story about our own sun development and later on the formation of our planet and later on other planets around our sun. And this will be a nice simulation understanding through this particular region lens and how these northern regions will actually spark conversations about this in the future. Finally, looking at the image contrast between the James Webb Telescope and looking at the Hubble Telescope image, we actually see some interesting view of the transition state from our hydrogen protons that are more closer to the specific trapezium cluster and moving down to below the Orion Bar. It's really fantastic to see that transition from the protons formation to later dissociation and then finally molecular gases formation right below that is noticed at the Hubble Telescope view. And then later on there is actually another image that was released by Creek Observatory, which is in Hawaii, and this shows an interesting view of a specific star that is right above, closer to the trapezium cluster. Overall, I hope you found this really informative in terms of the Orion Nebula. How is it formed, location in space, potential for the reasons maybe it is where our sun was actually formed and later planets were created, and other interesting facts about how its structure impacts the way it actually forms new stars, and maybe how this might change our understanding about how solar systems are actually created. All the same, I hope you found this really informative. See you on the next one. Stay smart as always and believe in yourselves.